So my name is Taras. I'm C++ developer, and I have 2 years of experience in computer vision and a little bit in front-end development. Why front-end development? Because last 2 projects, they were connected with computer vision and front-end. I decided to make this presentation to share my knowledge and some discoveries. Why we choose front-end? Only front-end. I'll describe it in one slide, but first I want to start with one answer. When I talk to my work mates, they ask me, do you know that JavaScript is slow and it's not for computer vision? I answer, yes, I know, but it's probably twice or 5 times slower than native languages, but it is possible to make some valuable projects. And you may say that it's not okay to make front-end only, but we have some benefits. And most of them are connected with time. If to compare front-end only computer vision with native programs, it has benefits of time. They are cross-platform, that JavaScript is cross-platform or cross-browser language, and you spend less time for coding. And another issue is user don't need installation. And it's great for business because customer spends less time for reaching some goals. And and I want to mention that such projects, computer vision, they often used for entertainment and just for advertisement. And all computer vision in web, which I present, is close to that. And if to compare with computer vision with front-end plus back-end, it has another benefits, like you don't generate huge video traffic, and if it's cached, you can just use it offline. Let's move further. There are some instruments which are present. It's some libraries which I found. First to RToolkit.js and RUCO.js. They, for augmented reality, they can track quick response markers and nothing else. And they just, you give a frame and you receive just transformation metrics. Next one, Tracking.js, it's just a little bit advanced library. It have some operations like blur, like fast and brief points and descriptors. And the last one, JSFit, is a library. It's much complicated, a little bit complicated, but it has some advanced features like ORB features tracking, optical flow calculation, even some hard cascade detectors. And there is one book, it's mostly about JS feed. You can find for 50% of book is about JS feed, and about 5% about tracking JS. And now I want to share experience about projects which we made at our company. Okay, first one was a research project. It was for potential customer where we did a research for augmented reality in web browser. We tried to do our best, but we didn't reach our goal. And we just, with Marta, she is here, wrote article. It's in DOUA and alexlabs.com. And here are some results. If we use, we tested on a range of devices and in different browsers. And here is slower and higher FPS. It's on the devices. If we used QR marker, we get up to 30 FPS. Another thing, we use color markers. It's present in tracking.js library, and we got it's really slow. And tried to use image matching with it was kind of ORB descriptors, and we got from 0 to 1 FPS. It was not so good, but we saw that we can do something with quick response markers. And next step was another project. It was virtual makeup. And here we got really great results. The main goal was to make real-time web application where you can sit in front of camera, and it will render, draw makeup on your face. Here just screenshot without makeup. I decided not to put it. But here you can see that it tracks face and landmarks on face. And we get really amazing results. And on laptop or desktop, we get from 15 to 30 FPS. And on smartphone, it was in average 5, probably sometimes 10 FPS. And now I want to describe how we reached such. I think that it's a great goal. And I decided to write test in C++ and JavaScript to compare how it works. And I tested on my laptop. So that's why every measurements are related to my laptop, but they are relative, and I think you can make some conclusions. So I took library delib and its implementation of surf, wrote small test and detected surf points with descriptors in different images. And here are results. It's 3 different sizes. And I used optimization flag 03. Okay, and the next thing which I want to present is method which you can use for every program written in C or C++. And the way you can do that is awesome.js. It's who knows what is awesome.js? Okay, I'll describe. It's a subset of JavaScript. It has some strict rules which you have to use in your code, and your program will run faster because of integer and float values. Because of the way JavaScript runs, it tries to use the faster ways. Okay, and so you don't need to know JavaScript. There is one compiler, source-to-source compiler, mscripten. This command is like you compile your program in C++. And its command, you compile your C++ code to JavaScript and you can use it. You can compile several modules and use it in workers. It's the implementation of parallel programming in JavaScript, and they can calculate what you want in parallel. It's called C code, which calculates length of string, and here is compiled code to awesome.js. As you can see here, it uses some vertical line O to mention that it's integer value, and it's use some hash heap here memory, and there are lots of such rules. And by these rules, it's easier for browser to understand how it should behave. And after I compiled my C++ benchmark to JavaScript, then I got this result. And it's 3 to 4 times slower, but I think that it's great.
Sure, but what's the hardware?
It's my laptop. It has i5 Intel 1.7 gigahertz. And it's just relative. I put this code to GitHub, and you can try it by yourself. So I saw that the results, they are not so great, but they can improve our thoughts about browsers and JavaScript. Also, you can use it's in your code. You can use macroses where you put JavaScript code, and it's great because you can even pass some values there, and it's great because you can use WebGL. WebGL is just rendering 3D computer graphics, and it has it has connection to a GPU. And next slides I will show you how it helped me. WebGL now is present in 95% of users in browsers, and it shows growth and it's popular, yes. And its code looks like this. Then you get context from canvas, and you can write just functions are similar as in OpenGL. And with the help of shader, you can improve algorithm. I didn't finish this algorithm, but I did part of it, and some part that I didn't finish, I measured how much time it can take, and I get such results. And here you can see that it's slower than just AwesomeJS code, but here you have a little bit faster algorithm. It has here bigger values because when you copy memory from RAM to GPU memory, you spend a lot of time and then you need to copy it back. And it's impossible to do it faster in WebGL. And what is next? I saw that there is one thing which can improve, but it's not popular because of browsers. They don't want to implement it. It's WebGL. It's computational language. So it's close to OpenCL, but now there is no browser with default support of WebGL. And for example, Mozilla said that they don't want to develop this because they're going to improve WebGL better than this. But there are some demos. You can install plugin from Nokia and use WebGL. And that's all. And thank you for your attention. Maybe you have some questions.
Any questions? Yeah.
Did you consider to install maybe some native plugin and use JavaScript only as a top layer? Maybe, for example, you can use OpenCV and make some plugin that you install on your browser, and then you use JavaScript only to communicate with the user.
Okay. The question was, can I do something about JavaScript and run some computations on Java, for example? Yes.
No. So you talked about that all the algorithms they were implemented using JavaScript.
Yes.
Yeah, and I'm asking, did you consider to use JavaScript only as a top layer, as a facade? And then on the back end, you'll use some native plugin that you install inside the browser. So it would be definitely faster.
Okay, I understand the question. It's possible, but I didn't do that because of constraints in project. We have to reach all users, and because of we need less time to reach the goal, and to remove installation of some plugins or native applications.
And another question, so you showed some plugins to JavaScript that generate the C++ code.
Yes, it's
C++ and JavaScript, is it correct?
It compiles C or C++ code to JavaScript,
Yeah,
yes.
and the question is how much effort you need to put extra to make it workable, because every code generation is not perfect. So.
Okay, scripting is close to Selenium, and there are some constraints, like you can't use files, but they have some manual how to write a little additional code to just emulate file system. Also, they have some troubles with some assembler code in C++, but a lot of I just used my code and just compiled it. I didn't have any troubles with it, and it's really easy.
So basically, the workflow, you just write something in C++ and then you generate it to JavaScript, yes?
Yes.
So basically, you develop most on C++.
Yes, yes.
We have another questions.
Yes. In last table, you compare three types of this, and I don't understand how you implement surf on WebGL.
It was only part of algorithm. It's part when you calculate pyramid. Then pyramid. I used implementation in the RIP. From the RIP used WebGL to calculate some part of pyramid calculations.
You use the shaders, yes?
Yes.
Okay. And second question: how much browser supports SMJS?
Okay. It's a great question. Sorry, I forgot to mention that if a browser does not support SMJS, it's easy for browser to. SMJS is written in such a way that browser can run it and with the same logic. But it's supported in all browsers except Internet Explorer, and but Microsoft's browser Edge, they have support of SMJS. It's great. And Opera for mobile does not support. It means that it just runs slower.
One more question. The idea of this project is to use some feature detector for augmented reality, yes?
Yes.
Did you try to use optical flow, for example, after detection to decrease very difficult, very hard computational operations? Instead of usage of surf or SIFT or something else, did you try, for example, optical flow plus Garrison corners or something else? Instead of 10 times of surf, you can do 1 time of surf and 9 times of optical flow. Did you try it?
Yes, I tried it. Thank you for the question. And There is implementation of optical flow in a JS feed, and it's easy for use. I used just Surf to make a simple test and to show that it has JavaScript is not so slow. That I used just Surf to show how it with comparisons of C++. Yes.
It's morning. We have 3 questions before the first speaker. It's something very interesting. So yeah, I will ask to give it. Yeah.
I have kind of troll question. You use Surf. Have you paid license fee? It's patented.
I don't use it for commercial. I just took it from the lib and it's free.
Did you try to use Metaio SDK for the augmented reality? It is also in JavaScript.
I tried it, but I tried it for native application for Android. And now Metaio was sold to another company.
Yeah, now it's for Apple.
Yes, and I didn't find their implementation.
Thank you.
But thank you, I will try it.
Any other questions? Okay. Taras, thank you very much. Nice presentation and nice answer on the questions.